3 days. It's the time most patients still have to wait for their antibiotic susceptibility test results. The World Health Organization predicts that by 2050, antibiotic resistance will cause 10 million deaths each year. For sepsis patients in particular, the mortality rate increases by up to 9% every hour. Therefore, the time it takes to find the right antibiotic is directly linked to survival. So what makes an AST result take 3 days? While it's critical to see which antibiotic is effective quickly for patients, conventional methods require the sample to still undergo a long process: plate streaking, overnight incubation, colony picking, and the McFarland standard procedure. This process takes a minimum of 48 to 72 hours to get the results. But PROTIA is different. After a positive blood culture and a gram stain, our AST can begin immediately. Using capacitance-based technology, it detects changes in bacterial growth in real time to quantitatively calculate the minimum inhibitory concentration. This is possible due to the unique properties of bacteria and the principle of capacitance. Bacteria carry a tiny electrical charge, with ions inside their membrane, making each one act like a tiny capacitor. On our sensor, we track this charge. If bacteria are resistant, they multiply, increasing the medium's dielectric constant and therefore its total capacitance. But if they are susceptible, they cannot grow, so the electrical signal remains stable. It's simple, yet genius. When antibiotics work, bacteria can't grow, so their electrical signal stays flat, with almost no change. But if they're resistant, they keep multiplying, and that growth changes the electrical response we measure. This response comes from capacitance, the ability to store electric charge. As bacteria grow, they make the liquid store more charge, so the capacitance gradually increases. Simply put, susceptible bacteria, almost no change. Resistant bacteria, capacitance keeps rising, detecting even the tiniest growth through electric signals. That's the core of PROTIA's AST technology. While conventional optical methods must wait for bacteria to become visible, PROTIA's innovative electrical method detects a reaction as soon as they start to grow. That is why our AST kit delivers results in just 4 hours. This clear data and streamlined workflow allow for rapid prescription of the optimal antibiotic, maximizing treatment efficacy, improving success rates, and enhancing laboratory efficiency. PROTIA Quick AST, performing rapid antibiotic susceptibility testing using capacitance. Shall we see how it's used?
Here are the main components of the equipment. Let's begin. First, press the PC power button. Then, press the main unit power button. Launch the software by clicking the icon on the desktop. Log in with either an admin or operator account. From the main screen, navigate to the heating deck menu. Select the desired deck and set the temperature. Each deck can be set between 30 to 40 degrees Celsius. After entering the temperature, press Set to save. Select the plate deck for the auto setting. For the auto setting, select the deck number you wish to use. Enter patient information and conditions. Enter the patient's name. Select SIR criteria. Select the bacterial species and chip type. You can also enter this information using a sample barcode. Select the PROTIA AST DL001 chip to use. Select the tips you want to use. Once all settings are complete, this message will appear. Please confirm your test and control samples. Press Yes to proceed. Once the settings are completed, this is the interface you will see on the equipment. All information necessary to monitor the experimental status in each section is displayed. To start the test, press the play button in the 4th section. The equipment first dispenses the control sample into the selected chip. The first channel on the bottom right is the position where the control sample is dispensed. 50 microliters will be dispensed into each channel. Now the equipment will begin dispensing the samples into the plate. Blood culture specimens are used as samples. Use the sample that tested positive in the blood culture. Prepare 12 milliliters with Muller-Hinton broth, diluted at approximately a 1 to 3,000 ratio. Samples will begin to be dispensed at 50 microliters into each channel. Through this process, when the sample is dispensed into the wells, the dried antimicrobial agent dissolves into the specimen before measuring the electrical capacitance of the plate. To accurately calculate the exact change in the bacterial culture, LCR meter calibration is performed. Once calibration is complete, the equipment will measure the electrical capacitance of each plate. Through this dispensing process, the dried antimicrobial agent dissolves into the specimen, causing a change in the concentration of microorganisms around the electrodes. The equipment measures the change in electrical capacitance in just 3 minutes. When it's done, a PDF result will be printed. Once completed, press the UV button to turn on the UV lamp for 15 minutes for sterilization.